Good. I would like to go through the math details of how to actually deduce the mean of the binomial distribution. If we are to use the definition of the mean of x of a discrete distribution, as you have been taught in the basic part, this would, for the binomial, look as follows. We would have to go through all the possible outcomes if we assume that x follows a binomial with n and p. We should go through all possible outcomes x and multiply by the density of x. That's the definition of, let me just put that, the density of x. This is the general definition. The density of the binomial, we should then plug in x. What does that look like? That is the binomial coefficient n over x. It's p to x, and it's 1 minus p to n minus x. And we have to try to deal with this one to find out what is really the mean of a binomial. Now, there are some tricks when you work with probability distributions like this. One of the tricks comes here. Actually, you're having a summation here going from 0 to n. But since we are multiplying by x here, the 0 term is just 0. So we could actually just omit it from the expression and just say x equal 1 to n, since, I mean, the 0 term is 0, so we don't have to actually write it. I will then also, because we're going to sort of dig into the binomial coefficient here, so I'm going to still write the x. Then I will write the binomial coefficient slightly differently. I will, let me put the definition up front actually, then we can take it in 2 steps. This is the definition of the binomial coefficient, n faculty, x faculty, and n minus x faculty in the denominator, and then we just repeat p to x, 1 minus p to n minus x. I will just continue here, and let me see if I can remember correctly here to what I would like to do. I would like actually to make my little trick. I would like to actually put the n, actually the x faculty here. The x faculty cancels out, or mean the x part of the x faculty would cancel out with the x from there. So I would have x minus 1 faculty. Then I'm going to do the trick. I'm going to take out one of the n's and then say that the n faculty is n times n minus 1 faculty. And then I'll just repeat this statement. And I'll repeat this one. Actually, let me just, now let me do it in 2 steps. This was the first part of the step. The thing is, I'm going to recognize another binomial that is shifted with 1 step compared to the original binomial. That will be the trick to actually make this into something that we can handle. The next step would then be to still x equal 1 up to n. I'm going to use the n minus 1 and x minus 1, so I'd like to write actually np, since I take the n from up here, take this n, and I take one of the p's from here, and such that I have p, only x minus 1 left, n minus p, n minus x, and then I have n minus 1 faculty, I have x minus 1 faculty, and n minus x faculty. And now I'm ready to do the final little trick, which basically, let me do like this so we can see it, basically is what you could call a change of variable. So instead of, I'm going to change variable, instead of x minus 1, I'm going to write y, and instead of n minus 1, I'm going to write m. So I'm going to recognize another binomial here by putting the x minus 1 as y and the n minus 1 as m. And please note, when we do this, then m minus y is exactly the same as x minus 1. Sorry. It's n minus 1 minus x minus 1, which is then also n minus x. So the difference would be the same between these two. If we do this little trick, then we are not summing x from 1 to n. We're actually summing y from 0 and up to m. Still we have np. We have, instead of n minus 1 faculty, we have m faculty. Instead of x minus 1 faculty, we have y faculty. And then we have m minus y faculty. We have p to y, and we have 1 minus p to m minus y. And now please note that I should have actually right away have put np outside, because it doesn't depend on y, so we could take it outside the summation sign. And then all the rest is simply a binomial summed from y to m. So all the rest simply becomes 1. And we have the result, hopefully well known to you now, that the expectation of, maybe I should just emphasize this a little bit, now I did it. Actually, we have a full summation over all binomial probabilities here by doing the shift. So we basically shifted it such that we could recognize a full binomial set of probabilities. And this full set of probabilities adds up to 1, which then gives, once again, the result. That's the mean of the binomial.